Um, okay. All right, let me talk about problem number 33, section 8.3. Okay, so this is yeah, find the centroid of the region bounded by the following curve, x plus y equals 2 and x equals y squared. Right? So first one, you have to sketch the graph, right? So sketch the graph. X plus y equals 2, you just need to find 2 points, right? When x equals 2, y 0, when y equals 2, x is 0. So this is a straight line right here. Okay. Then x equals y squared is parabola open to the right. So that's a parabola open to the right. So clearly, as those two curves intersect at 2 points, you needed to yeah, draw the graph first, right? So this is a picture, okay? So let's color the region. So I think at least we have to find the intersection points first before we solve the problem, right? So how to solve the intersection? Or just solve the equation. By the first equation, x is going to be 2 minus y, and that's supposed to be y squared, right? So you solve for y first. So y squared plus y minus 2 equals 0, and you can you can factor it, right? So you will get 2y plus minus y is plus 1. Okay, so I can get y equals 1, y equals negative 2. So I'm pretty sure this will be negative 2, this will be 1. Okay, then you determine the x coordinate. X is 2 minus 1 is 1. So that would be 1. Yes, x is 2 minus negative 2, which is 4. Okay, so you got 2 points. Okay, so we have done the preparation. Now, the question is how to find the x bar and the y bar. Okay. Okay. So the idea is very simple. So you collapse to the y-axis, okay? And if you have then you get a density function. The density function is the length of that piece, okay? So that piece is going to be the length is going to be yeah. So the density function is rho at the point y is going to be the length, okay? So the length this is the length of this horizontal line segment. Depends on what, right? So the y bar, the center, okay, of if all the material accumulates along this line, right? So you get the y bar. The y bar is going to be the integral of okay, of the total mass, right? So I think from negative 2y, so to positive 1, and the rho over y, dy. And this would be negative 2, 1, and this is y rho y, right? So that's the formula. Okay. All right, so you get y bar first. Y bar is much easier to get. Okay. The difficult part is to get x bar. Now, since this is a picture, you cannot collapse, project this whole region onto the x-axis. Okay, because it's very difficult to calculate. If you get piecewise define the density function, well, it still can be done, okay, if we want. Okay, we can try 2 different ways to find x bar, okay? But y bar is very natural, just project the whole region onto the y-axis. You look at the shadow, some place more dense, some place less dense, right? So the density function is used to calculate the centroid of the center of mass, actually, the center of the mass. This is actually the center of mass, okay, on the y-axis, right, for the projection of the region, okay, onto the y-axis. Okay. All right, so let's find this density function. Okay, I have to draw the picture again because it's the screen's too small, right? Okay, so the density function, this is the one, that's gonna be -2. The density function for the y variable is just the length. So this is the x, this is the difference of the x, okay? And for the same y, this x is gonna be 2 minus y, and this x will be y squared, right? So the difference will be, so the density function, the length of this onto this point, okay, is going to be 2 minus y squared. All right. So so the integral from -2 to +1 of this density function actually is the area of that region, okay? But this also is the mass of the projection of that region onto the y-axis, okay? Okay. Yeah. So that is yeah, because of total, right? So this actually gives us the mass, the area of the region. Okay. So area of the region. Okay. Actually gives the area of the region. Okay. This also is going to be the mass of the projection of the region onto the y-axis. Okay. Okay, let's calculate. Okay, it's not a big deal, right? So you, okay, okay, let me turn off my phone. Okay, yeah, otherwise I got TV messages. All right, so the antiderivative function 2y minus 1/3 of y squared minus no minus 1/2 of y, 1/3 of y cubed, and evaluate the two endpoint. So let's evaluate. Okay, minus 2 times -2. This is a part to be careful about -2 squared, about 1/3 -2 cubed. Okay, so you simplify this. I need a scratch. Okay, so this is so let's see. So it's 2 minus 1/2 minus 1/3, and the negative and positive, and this is also would be negative positive, right? So actually it's positive 2. Why? Because it's 2 cancel out, 2 square, you know. And then I have a negative sign here. The reason is -3 negative, so -8 times 3. Okay. So great, you're going to get, actually is going to get a kind of, not necessarily integer, so 2 plus 4 plus 2, 8, minus 1/2, 1/3 minus 1/8 is 9/3. So that becomes 3. So we, 5 minus 1/2. And let me put a 9/2. Okay. Okay. So that is the total area. Okay. So the question is, how can I find the x bar? Okay. How can I find the x bar? Okay. We still use yeah. We still use the idea is that we still use this for the given y. Okay. So so this is we use a formula. Now the book gives the formula, right? So actually, what I'm trying to do is draw the one line segment. For every point, I get the center. Okay, that is a center. Yeah, there were a couple formula to use. Okay, this is the first one. This is the length. The length is a density function, right? The length. Okay, so this is you have the length rho of x is going to be, the difference of, right? So it's going to be 2 minus y squared. And then I also want to find out the center. So that's the center, this point. we can denote by denoted by let's use h of x. Okay, the cent. Okay, so it depends on y value. So the cent, the cent of this line segment. So c of x is going to be the half of the value, 2 minus y plus y squared. Okay, yeah, yeah. Okay, so this is the one. Now the formula we derived before is x bar is going to be what we have to doing here is we actually find out the formula. It's from -2 to +1 rho of x dx dy, and this will be the integral of that function multiplied by this. Okay, if you still use want to use the y variable, so only and actually this is in the book. There's already have a formula. Just say half of that, and then this is a minus, right? This is a plus. So actually, it's going to be 2 minus y squared minus y squared. Okay, dy. When you multiply this out, okay. Yeah, this is a little bit harder to understand the formula. Okay, so the denominator is just 2 minus y squared dy, and then we get the same result. So all we have to do is just evaluate the one on the top. Okay, so evaluate this integral 2 minus y squared dy. Let's see if my computation is correct. I have to divide by 2 later on. Okay, so before minus 4y minus y squared minus y to the fourth power. Okay, so there are many terms here. Unfortunately, it's 2y minus 2y squared plus 1/3 y cubed minus 1/5 y to the first, and evaluate it to end points. Okay. All right, so you get 4 minus 2 plus 1/3 minus 1/5. That's the first part. Second part, you have to put a negative sign. So after you get simplifying this, it's complicated, right? After you simplify this, and then you get x bar, so you get a centroid, the x coordinate of centroid. Okay, you have to multiply by 2, right? And well, so yeah, let's figure it out. Okay, I hope I can do addition. All right, this is let's remove all the parentheses. Okay, so minus and minus plus, it's 8. And this is should be plus, so it's also 8, right? -2. -2 times 4 is 8. That was positive. Okay. This will be negative, but also be positive, okay? Because this is a 8 over 3, okay? And then how many negatives are here? Negative, positive. So this will be negative. 2 to the 5th, okay, is going to be 32, right? All right, so now let's simplify it. It's complicated. I have to say that. And this integers together, right? 16 plus 2, 18. And 1/3 plus 1/8 is going to be actually 1/3 plus 8/3 is going to be 3, right? Then here is be 30. Unfortunately, we have 33 over 2, over 5, yeah. So that is going to be 21 minus. Let's combine. 105 minus 33. Okay, that is going to be 2 and 72. Okay, 72. And they have to multiply by 2, right? So my x bar, at the end you double check whether this is a reasonable answer, right? So x bar is going to be twice of 72 over 5. And we also have the same denominator. Okay, oh, it's not twice, it's 1/2. Sorry, it's 1/2, not twice. Yeah, so be careful. 1/2 And the denominator, it's the same. We already get it. It's a 9/2. No, not a 9/2. It's what do we got here? We haven't got a, yeah, we just evaluated this. No, we actually haven't get to the y bar yet. We just evaluate this total area. Okay, it's 9/2. Okay, so 9/2. Okay, we can simplify it. 75 times 2, and here's 9/5. 9/29. So cancel, right? And 72 divided by 9, right? 8. So 8/5. Okay, so that is x bar. Okay, that is x bar. I haven't got x y bar yet, but let's look at the picture. 8/5 is a reasonable 8/5. Where's the center? Yeah, go back to the picture. Okay, this is a 4, right? This is 0. X bar is 8/5 is slightly more than it's more than 1. Okay, so somewhere here. Okay, and this is a 2. Should be on the left side of 2. So 8/5, yes. So this is should be the x bar. Okay, and the y bar should be negative. Okay, y bar should be negative. We haven't got the y bar yet, so you have to evaluate y and the root of y. You wanted to get y bar, right? Yeah, you have to evaluate this. Okay, so okay, yeah, and again, the computation is it's not simple. Okay, then you find the antiderivative. So y squared 1/3 y cubed minus 1/4 y to the 4th power. Okay. Yeah, let's finish this. Okay, 1 minus 1/3, 1/4 minus -2 squared. Okay. Okay, remove the parentheses first. Don't combine them. Okay. Sometimes it's more complicated. Then you saw that's a 4. I have a negative, and 3 negative signs, so it's going to be 8/3. And then I have a negative, positive, so it's going to be 2 to the 4th power is a 16. So divided by 4 is just equal to 4. Okay, it's a positive. Okay, so this cancels out, right? And this will be 1 minus a quarter. Negative 1/3, negative 8/3 is going to be -3. So it will be, right? And then it will be 9/4. Okay, so y bar is going to be 9/4 divided by, I think it's 9/2, right? We got 9/2. Okay, so it's going to be 1/2, negative 1/2. Okay, I think that's reasonable. And let's put it in the picture. Here, this is a picture, right? So here, this is a 4. I think that's a 2. I need to draw it correctly. Okay, so that's let me reschedule the graph here. So it's okay. Let me carefully sketch the graph. Okay. So I want to see there's no competition in my calculation. Okay. So you draw scale, yeah, 2 2s here. That's a 4, right? And you extend it, and this when x equals 4, the y is right. What is it? X equals y squared. X plus y equals 2. That's 2. I think. What do we got here? When y equals -2, x is going to be 4, right? Yeah, x is 4. So this is a graph. Here's a 1, the 1. Here's 4, negative 2. Okay. So our center, y bar is x bar we got it. Here is 805. 805 is somewhere here. So this is right, somewhere here, right? And this will be negative 1/2. So this is 1/2, this is negative 1/2 is here. So guys, this is 1, right? Negative 1, negative 2, negative 1/2. Okay. So this will be 805. So somewhere here, and you look at the picture, yes, this should be centroid, then no computation mistakes. Okay. Now, this is a very bad picture, okay? We can think about how to get x bar. Use the same idea. You project the region onto the x-axis. If you project the region onto the x-axis, you still can get x bar. Okay, but the problem is how do you find the density function? Okay, so this will be here 1. Here's a 4. Okay. So the trouble is for an arbitrary point, right? This will be the length. Okay, this is length. So if you want to find the density function, yeah, this will be the length. This will be the length of the line segment, right? So x bar is going to be integral from 0 to 4, and x rho of x dx. And denominator is this. But this is the same. This is already denominated 9/2. This is a 9/2, right? This is 9/2, and we already did the calculations. This represents the area of the region. Right? We already have a 9/2, yeah. Okay. All you have to do is find the rho of x. The rho of x is a piecewise defined function. You know why? Because this is a critical point when x is between 1 and 0. And that is actually is going to be double of this, right? X is going to be, right? X is going to be y squared. So y is going to be plus minus square of x. That's 2 pieces here. So it will be double square of x. Okay, because from here to here, just fine, right? Yeah. For the same x, the lower part will be negative square x. The top part will be positive square x. So the length is going to be double x. But for x greater than 1, less than 4, right? And then the difference of those two functions. Okay, the lower part is still x, negative square x. The top part, you have to solve for y. Y is going to be 2 minus x, right? If here first is x, then y is 2 minus x. Okay, so the difference is it's minus negative x, it's plus square x. Okay, 2 minus x minus negative square x is this. So this is a piecewise defined function. You stay able to get it done, right? So in order to evaluate this integral, you just evaluate to each point at dx, and from 1 to 4, and here's x, 2 minus x plus square x. Okay, I guarantee you will end up with the same integral. Okay, which is going to be, what do we got? This is okay, what we're doing here? Yeah, we are going to find the x, right? And the x bar, this gives you, I'm pretty sure this gives you the same answer as this, okay? So it will be 36/5, I guarantee you, okay? So this is a 36/5, okay? So yeah, x bar will be 36/5, 9/2, and that will be 8/5, okay? The same result, okay? But much easier to understand, using, in order to get x bar, you project the region onto the x-axis, and you get a density function. Okay, then you get the centroid of that projection, the shadow, okay, of the region. Okay. Yeah, but there are some other problems maybe a little bit easier to do computation. For example, such like this one. I use a vertical line instead of this x equals y squared and the intersection, right? And when this is when y is negative, x is positive. Now find the centroid. First of all, the centroid must be here, x bar y bar, right? Find the centroid. Okay. In this case, you don't need to waste time to find the centroid. Find the y bar. Y bar is clearly 0. So don't even try to do that problem like that. All you have to do is find the x bar. Okay. Find the x bar. There are a couple ways to, the natural way is to project the whole region into the onto the x-axis. Okay. So the density function at that point is the length of that line segment. So rho of x is going to be double y, right? So square of y, square x minus negative square x. So it's actually 2 square x. Okay. So you get the density. So more dense on the right hand side than the left hand side, right? So yeah, the centroid of this this portion of the on the x-axis, right? The projection of the region should be on the right hand side. Okay. So now x bar is going to be the integral from 0 to 1 rho of x dx. Integral from 0 to 1 x rho of x dx. Okay. Yeah, that's the easy one. Usually we put a problem like that on the quiz as long as you understand, it's 2 square x, and this will be 2 x square x. Okay, dx. So you find the entire derivative of each of them. Okay, so let's do it. Okay, so this will be 2 over 3 x to the 3 over 2, right? And you evaluate the endpoint, it's 2. This is 3 over 2, so 2 over 5 x to the 5 over 2. Okay. Yeah, when you differentiate, you get x to the 3 over 2. So at the end, you will get 4 over 5. 4 over 3 is the answer to 3 over 5. And you look at the picture, yes, this is a greater than 1/2. It's more close to 1. So that is correct answer. Okay. Yeah, that'd be much easier. Okay. Right. Yeah, let me repeat again the idea. If we have a region in the space, okay, how to find the centroid x bar y bar? First of all, you project to this side, you can get x bar, so you get a density function. So you get, this whole region collapse to the line, and this point have more mass, right? The mass at that point, right, it's going to be determined by the density function. So density function is the length of this line signal. Okay. Okay. The length of the vertical line segment inside the region. Okay. Then x bar is just the centroid of the projection of this region. Okay. And this is how to calculate. And that's the formula, remember. And then you do the same thing. You can project to here. Okay, that's from C to D. And then at every point y, then you get a horizontal line. And that's the then you also get a density function along this line, and that tells, right, kind of density function. So you project the whole region into the y-axis. And so the y bar is the central. The y coordinate of the centroid is going to be the centroid of this pole, this projection on the y-axis. Okay, so y bar similarly. So from C to D, rho y dy, C to dy, rho y dy. Now, the question is, do they have the same denominator? Yes, because this part is the same. That should be the same because this is actually going to be the area of the region. And so once you compute one of them, then you just don't need to repeat it. All you have to do is to evaluate it as integrals. Okay, but if you don't want to change the variable, then you have to, we derive the formula already. If you don't want to change the variable, you still want to use the x variable. Here, the idea is very simple. You have to find the centroid. I call the cx, the coordinate. Okay, depends on x. Okay, then use the density function. You have to find the average value of the roughly speaking, when you're talking about this kind of, this is going to be, this actually, the average value of the height, right? This integral always represents the average value of height. This is the height function of the center of this line segment. So when you go from left to the right, right? So what is the average height? Use this integral to get the average value of the height. And that actually gives you the y coordinate of the centroid. Okay. Okay. The geometric meaning of this is that, if the average height, right? If the average height of this this height function. Okay, this is a height function of the center of this line segment. Okay. So you can always use this formula to find it. In reality, in a specific example, if you have the top one y equals f of x, the bottom one is y equals g of x, then you will see that cx is just half of f of x minus g of x. Okay, and the rho of x is the density function. Now this is the average value. It's the difference of this two functions. So the product when you multiply this out will be 1/2 a plus b times a minus b, just f of x squared. You were wondering where is this from? Why is f squared minus gf squared? Just because it's a product of the height function of the center, the middle point, okay, of the line segment, and the product, and was a density function. Okay, that's why you get the f squared minus gf squared. Otherwise, you don't know where this is from. Okay. Okay. Yeah, those are the problems. I spent half hour on that. Okay, that's okay. Yeah, I said that we're gonna have plenty of time to go over the test. Yeah. Okay. Right. So let's go over for the test. The first problem I want to discuss is if you have f of x, right? And that is going to be like 1 plus, for example, 10x and minus cosine x, something like that, right? And I want to find out the derivative inverse and Yeah, that is going to be, could be 0, could be, I can put 2 here, then that'll be 1. Okay. Now, what does that mean? Well, first of all, you note that couple things. One is f of 0 is going to be 2 plus 10 times 0 minus cosine 0, which is going to be 1. Second, the derivative is going to be 10 minus a plus sine x. But this is never be negative. It's always positive. So f of x is increasing. So that means the inverse exists, okay? But I cannot find the formula. So that means, in other words, so-called inverse exists means one can, roughly speaking, one can solve this equation for x, okay? So you're supposed to get x is going to be the inverse of y. Now, are you able to express the inverse function using elementary functions? No. Okay, nobody can solve it. Okay, but I know for the given value of y, I can get the unique value of x because it's an increasing function. Okay. We also know that, at least I know that by the first one, 0 equals, right? So the inverse value, the 1 is going to be 0. That's I know. Okay. 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 So how do I find the derivative? You have to write down the formula. Right? Write down the general formula. This is going to be f prime. Right? This is general formula. So when if you want to find the derivative at 1, you have to use this formula. And then I already know that that's going to be 0, right? F the inverse value of 1 is 0. So what is the derivative? We have to find the derivative. We already find the derivative. So derivative is a 10, right? Plus sine x. Okay. So that is a derivative. You see the derivative is 10 plus sine x. So when x equals 0, that's what we got. So it's going to be 1 over 10. Okay. So that's a complete solution. Okay. Our second problem is the integral of x. We have to get familiar with hyperbolic sine x. Okay. And this type of problems are very similar, like x e to the x, and here's x, natural log of x dx. We no, probably not. This is a different. Okay, so I will talk about this problem later. Okay, what we want to do is we want to get rid of x in this case, not as a function. As a function, when you differentiate, never changes the nature of this function. Okay, e to the x, derivative is e to, and the derivative hyperbolic sine x is still, cosine, hyperbolic cosine. So what I'm trying to do is, this will be dv. Okay, when I switch it, then x is 1. Okay, so the question is, what is that? V, right? V should be equal to hyperbolic cosine x. Right? Because when you differentiate hyperbolic cosine x, you get hyperbolic sine x. Okay, so it's uv minus v du. Okay, it's going to be u, it's going to be x, v, hyperbolic cosine x, minus hyperbolic cosine x dx. So the entire, no, there's no integral here. Yeah, so the entire derivative of hyperbolic cosine x will be hyperbolic sine x. Okay. So what I want you to do, try is think about this one. Okay. It looks similar, right? But probably it's a slightly different approach. Yeah, please work on this problem. All right, so let's work on this problem. I hope you solve it. All right, so in this case, you cannot use the same exactly the same way to get rid of x. There's no way you can get rid of x. What you should do is you switch the order, okay? And that will be dv, that is u. Then when you du, natural log is gone, okay? When you differentiate u, right? So what is a v? V is half of x squared, okay? So uv minus v du, right? All right, u is the natural log of x, v is half of x squared minus half of x squared. Derivative of u with respect to x will not x dx. See, then natural log is gone. Yeah, so let's write in this way. So here's 1/2. The integral of x, the antiderivative of x, half of x squared. So that's what we get. All right. Okay, so slight different, right? And is there any other similar problems you can natural? Yeah, example. I give example. Okay. The integral of integral of even integral of this one, right? No, I don't want this. Let me give you another one. Now there's some other problem. It's a mixture. It's like a x cosine x cosine x dx. Okay. X times cosine. Yeah, cosine x dx. Okay. And another one will be x times sine x dx. No, this is a still the same problem. Yeah, I'm putting e to the x. E to the x. Okay, got it. So so you're not able to get rid of a cosine, get rid of e to the x. Doesn't matter which way you do. Okay, if you try this, and this is dv, that's a u, right? What you get is v is going to be sine x, right? So you get uv minus vd, right? Okay, let's see. And u is the e to the x, v is going to be sine x minus sine x, e to the x is still this. See, the only change is from cosine to sine. Of course, you can continue, repeat it. Then you can solve the problem. Okay, but you're not really get rid of e to the x, changes the nature of the function. Okay, right? So so you have to you have to work on in the same way. Okay, I needed to switch it. It's going to be e to the x sine x dx. Okay. So this is still my u, this is my dv again. Okay, so v equals negative cosine x this time. And the uv, right? U times v, it's going to be e to the x times negative cosine x, and then minus, it should become positive. Okay, so e cos dx. Right. So then you have e to the x sine x plus e to the x cosine x. Then you have minus e to the x cosine x dx. But you begin with you come back again, right? But this come back with a negative sign. That's good part. We begin with this. Okay, we begin with this. You end up with this term minus that term. So that's why, and clearly e to the x dx should be equal to half of this. Okay, and plus constant. You have to apply the integration parts twice. Okay. Now can you? I think this will be the only method we can use. Okay. All right. So let's take a look at the next problem. It's about integral sine x 1 plus cosine square x dx. Okay. All right. I give you a few seconds to think about the best way to solve the problem. Okay. Let's see. Right. So the natural substitution will be u equals let u to be cosine x. Okay. Then you will see that you have to complete this part first. It's negative sine x dx, right? Differentiate u with respect to x. Then the integral becomes 1 plus u squared. Sine x times dx is going to be negative u. Okay. So that should be the easiest, the simplest way to solve the problem. You don't need to separate. Okay. Some things just separate, multiply them out, then use substitution. Okay. So that is going to be negative 1, negative u. So it's negative u, negative 1/3 u cubed. Right? That's the entire derivative. And then you put cosine x back. That, yeah. So you make observations first to see if you can use a simple substitution solve the problem. Okay, you can use simple substitution solve the problem. Okay. Here's another one, like x 1 plus square 1 plus x squared. Right. Right. When you look at this, you see, oh, in the denominator, it's a square root 1 plus x squared, and the numerator is x. So it's very natural to use as a substitution. The more exercise you do, and the more experience you get, and you can quickly find the right method to solve the problem. Right? So this is a bit, something maybe you say, oh, I see 1 plus x squared. So should I use a special substitution for x? X equals tangent theta or something like that, right? Because we know that 1 plus tangent square theta, you can get rid of this radical. Here I'm not going to try to get rid of the radical. Okay, you probably still can solve the problem, but it's just more complicated. Okay, but so I'm not going to try to use this type of substitution because 1 plus tangent, I know 1 plus tangent square theta is going to secant square theta. Then square root of that will be, radical, right? You can get rid of radical, but that's not the best choice. Okay, so then you will get du equals 2x dx. So the integral becomes square u and half of du. Okay, u to the negative half du. Okay, so the entire derivative, you can use this formula to find it. Okay, so you will get 2 times 1/2, just one, u to the 1/2 plus constant. So u is going to be 1 plus x squared. Okay, that's how to get like that. So this substitution is the simplest substitution you can choose. Okay. Yeah, you may try, right? Let x to be tangent theta. Here we did not get rid of radicals. We just make the function simpler. But you can get rid of the radicals. Then maybe you can try it, right? So if you use if you go into the wrong direction, sometimes still you can come out and solve the problem. But does not mean it's the best solution. Right? You can try this, Then 1 plus x squared equals tangent square theta plus 1, right? And that is going to be secant square theta. Okay, so it's 1 plus x squared is going to be secant theta. And the same dx is going to be, I think, secant theta tangent theta, right? D theta. The derivative of tangent theta is going to be this. Okay, so the integral is going to be here secant theta. X tangent theta, and then the dx is a derivative, right? So that is going to be secant theta tangent theta, and then d theta. So secant theta cancels out, you end up with a tangent square theta. Wow. Okay. Tangent square theta, how can you do that, right? So is there any other, derivative equal to tangent square theta, right? Right. So it's getting more complicated. You cannot. You maybe modify this function. Sometimes you're given the integral of tangent square theta. Evaluate this, right? Then you have to solve this integral. But our goal is to evaluate this integral, x over square 1 plus x squared. Now we make it, I think, make it harder, not complicated, even hard, right? So tangent square theta is sine square theta over cosine square theta. And yeah, I don't think that's a good way to do it. Okay, you may use a double angle formula. Okay, double angle formula, sine cosine 2 theta. Okay, sine 2 theta. Yeah, that's a possibility. Yeah. Remember the integral sine square theta, right? The integral sine cosine square. Right. Okay. And we use a double angle formula. Okay. Tangent 2 theta. Okay. Tangent 2 theta. No, I think it's just much harder.
Question.
Okay.
I have a question. The ds,
Yeah.
the ds equal to the secant theta and tangent theta d theta. Maybe ds is equal to secant theta d theta. There's no tangent theta there.
Oh, let me double check. Oh, that is a derivative of sorry, it's a derivative of secant. Yeah, derivative of tangent theta. Yeah, is a secant square theta. Okay, right? Yeah, then it's correct. Yeah, the derivative, the derivative of a tangent theta, okay, is going to be when you square the x is going to be that. Okay, so that is a secant square. I memorized it wrong. Okay, so my memory is got trouble. Yeah, so I did not check this. Yeah, you're right. So maybe you can solve the problem. Okay, so after that. Yeah. Tangent theta is sine theta over cosine theta. When differentiate, you get the denominator, you get cosine square theta. The numerator become 1. Yeah. Yeah. So derivative of secant theta is secant theta and tangent theta. That's right. You're right. All right. Now you can you can sum. Then this is going to be antiderivative of secant theta plus constant. Okay. Then secant theta is related to tangent theta. Okay. Secant theta is related to tangent theta. This is going to be square root of 1 plus tangent square theta c, and that is 1 plus x squared. And you end up with the same result, but you see, go through all so many different steps. Okay. You're right. Okay. But yeah, confused. Yeah. So it's hard to memorize without looking at the book. It's hard to memorize all this kind of formulas. After a while, maybe when you start that particular section, you know all the formulas, but later on you will forget. But you have an open book test, yeah. But still have to go back, check, find out, right? You can look at the back side, right? But you see, the same problem can be solved in different approach, but the second one is more complicated. Okay. All right. Now we have the so-called integration. partial fractions. So we have something like this. Okay, we're trying to evaluate this integral. Now the degree of the numerator is less than the degree of the denominator. Okay, so according to whatever the theorem, it's guaranteed you can change it to the sum of these two parts. Okay, x minus 2 plus bx plus 3. So you can determine the coefficients. Okay. Now you may ask me what happens if we x minus 2 squared, and then it's a slightly different. Okay. If I change x minus 2 to x minus 2 squared, okay, you have addition terms. All right, so let's find out the coefficients. So it's a x plus 3 and b x minus 2. Okay, and then a plus b should be equal to 3. 3a minus 2b should be equal to 0. Right? All right. Then you solve these two equations. How to solve these two equations? Well, use a quick way to do is you modify the first equation, 2a plus 2b equals 6. Then you add these two together so I can get rid of b. So 5a equals 6. So a is going to be 6 over 5. Okay. Yeah, add them together. So when you get a, then you can get b. B is going to be 3 minus a. 3 minus 6, 5. And that's 15 minus 6, that's 9 over 5. Okay. So you get a and a b, and then you solve the problem. Now, if you don't have a time, run out of time, what you should do? You should, you should write like this, okay? I know I can express this in this form. I just ran out of time, right? So you don't find a and the b first, but you write down the key ideas, okay? Then the first term is a, natural log of x, right? The second term is natural log b. So you say, as long as I can find a and the b, I get answers. So that is answer already. So where a and b, then you already find a and the b. So you then say a is given 6 over 5, okay, and the b is 9 over 5. Okay, if you run out of time, just stop there. You don't need to determine the coefficient. Okay. Now, if I change the problem a little bit, this is 3x dx. Here's x minus 2, as I mentioned earlier. Okay, what kind of decomposition you can get? Just because there's x squared there. So according to the book, you have to have two terms: a, x minus 2, b, x minus 2 squared. Then c is 4x plus 3. Okay, so you should have 3 terms. Again, if you ran out of the time, you just assume you already get those constants. Then the integral is going to be, the first one is a, natural log of 3, right? The second one is not natural log, because the second one is just like a 1, like a bx, right? So actually it's going to be negative b x minus 2 to the negative 1. When you differentiate, you get that. The third one, and plus constant. So you have to find the a, b, c. Okay. You have to find the a, b, c. Okay, so you get a system of 3 equations. Then you know how to find it, right? So let's try it, okay? I'm going to get a, b, c, yeah? So first of all, x minus 2 squared a, x minus 2 plus b, and this is c, x plus 3. Then it's getting complicated, okay? So x minus 2 squared x plus 3, and this will be ax minus 2a plus b, right? X plus 3 and plus c. and here's x squared minus 2x plus 4. So let's try to multiply this out. Okay, how many terms I'm going to get? To get a x squared minus 2ax plus bx and plus 3ax minus 6a plus 3b. Okay, you have so many terms here, and the coefficients of x squared will be a plus c, which is going to be 0 because there's no x squared there. And the linear term here is negative 2a plus b, right, plus 3a, and here's minus 2c. That should be equal to 3. And the constant term here is negative a plus 3, negative 6a plus 3b. And I have a 4c equals 0. So those are the three equations. Not too bad. This equation should be simplified a little bit. A plus b minus 2c equals 3. Okay. So you have to solve a system of linear equations. Okay. What I should do? What I have to do? Okay. I'm going to get rid of. I can get rid of c or a. Okay. So by the first equation, a is I solve for b and c first, then maybe. Yeah, or you can solve for c, for a first. So let's see to be a. Okay, by the first equation. Then a plus b minus 2 negative a equals 3. It's the first equation. So let's simplify this. So I have a 3a plus b equals 3. Okay, that's equation 1. I'm going to keep it. Okay, 2a. Okay, then 6a plus 3b is this, now this equation, right? Plus 4, negative 8 should be 0, right? So let's simplify it. Negative 6a, negative 4x, negative 10a plus 3b, 0, 1. Okay, so that's my equation 2. But it's not that easy to solve this equation. This I'm going to solve for b, 3 minus 3a. I'm going to put it here. Okay, and I'm going to get negative 10a plus 9 minus 9a equals 0, 1. So it's, 19a equals 9. So it's really bad, a constant. It's not easy, right? So I also have a c equals negative a, so it's negative. Now what is my b? B is a 3 times, so 3, 1 minus a, right? Times 3. 1 minus a times 3 here, 1 minus 9 over 19. 19 minus 9 is 10, so it's a 30 over 19. So you get all those coefficients. All I have to do is just put them into the formula. Now, be careful when you do the computation, okay? I cannot guarantee my computation is always correct. I did it pretty fast. Okay, sometimes it's possible you copy the number to the next step. It's negative sign. Forget to change the negative sign. Okay. When I was undergraduate, I don't remember I ever got 100% on any of the testing calculus. But I did pretty well, honestly. I got pretty well. I got like a 98%. Okay, I always somewhere lost some points. Okay, I knew how to do it. I just when you do the computation, it's easy to make mistakes. Have to be very careful. And there's a pressure, the time pressure. Yeah, you're not able to, come down and do the computation. Yeah, finish the computation. Okay. So my next, do we have time? Almost have no time. Just do one more problem, okay? I promise this will be short time, okay? So given a function e to the x squared plus 2 natural x, I want to find the derivative of this, okay? So all I have to do is just, this is a, if you know how to use a channel, this is a trivial problem, okay? It's easy to get the clearance, okay? So dy over dx, right? We just differentiate by the channel. This part, you can say y equals e to the y to the, sorry, y e to the u, right? Okay, and the u is going to be x squared plus this. So that's why this is this is like a dy over du over dx. That's channel. So e to the u, it's not changed because it's this e to the u, right? And du over dx is going to be, u is going to be x squared plus 2 natural x, and it's 2x plus 2, 1 over x. Right? Then that's it. So simplified. Okay. Simplify, then you get answer. Okay. That's it. So I stop here. We're going to have a, you have to go over all the quiz problems, and then go over the homework problem you did. And then if you still have questions, you can ask me in the next class. So I said we have plenty of time.